Welcome to Oceanography. This video will kick us off on our first unit, 7A. I want to make sure you understand a couple of things that you're going to see in the upcoming videos that are from the City College of San Francisco, because in those videos, the narrator assumes you've already had discussions about plate tectonics, and we have not yet had those discussions. So I want to give you a little bit of background so you understand when she refers to that topic. And don't worry if you're not clear on exactly what she's talking about. Hopefully what I'm going to show you right now will clear it up enough for you. So what am I showing you here? First of all, there's this pretty cool picture that I like right here. This is the Atlantic Ocean with the water missing, and it's a caricature. It's not a real picture. There's a lot of vertical exaggeration, but it's showing a couple interesting things. First of all, it's showing the true edge of North America here. You can see the boundary of Canada and the United States here, but you can also see the blue ocean continuing a little bit further, and then there's this steep drop off. So this is what we call the margin of the continent, and it's actually a little further than what we call the coastline because sea level is a little high right now. So you're going to learn about continental margins, and this is what we're talking about when we talk about the margin of the continent. Sometimes it's farther than the coastline, and this is one of two kinds of continental margins called a passive margin, meaning that there's no tectonic activity going on here. Now there is a plate tectonic boundary in this picture, and that's this large scaly looking thing in the middle of the ocean, and this is actually a mid-ocean ridge where this plate over here, which is the North American plate, and this plate over here, which is the African plate, are actually moving apart from each other at a pretty slow rate. But this right here is the place where they're separating and brand new ocean is forming. And so that's a divergent plate boundary. So you're going to hear that name in some of the videos. Notice that there are other features on the seafloor here, little dot-like almost hills or volcano-like things. And again, these are exaggerated. These are called seamounts. So you're going to learn that the seafloor is not just flat and featureless. There are things on the seafloor. This is showing one way that we can map the seafloor through the water, and that is by satellites, believe it or not. Ships can also travel on the water and send beams down to the surface of the seafloor and measure the depth so we can get a map that winds up looking something like this. Over here, this is a microscope slide of a bunch of little tiny organisms, plankton basically, that have little shells. And actually, when it comes to plankton, we don't call them shells, we call them tests. And that's the same word as an exam or a quiz, a test. But we say those are little tests. And these are all made of silica, and this is a type of sediment that forms on the seafloor. And in fact, we use these little things. These are called diatoms. And you probably use them today. These are found in your toothpaste. What do you know about that? Okay, so let's move on. Here are the learning outcomes for 7A. So go ahead and pause the video and write these down. So one word that's important to learn is the word bathymetry. Bathymetry is the measurement and charting of the shape of the seafloor, or the topography. If you know the word topography, that's your elevation above sea level. If you've ever gone hiking with a topographic map, it tells you how far you are above sea level. Well, bathymetric maps tell you how deep you are below sea level. Ships can calculate the depth by sending down a signal and timing it, and they can just use the simple speed equation to figure out how deep it was by figuring out the time that it took for a signal to go down and back, and they know the speed of the sound in water, and then they get the depth. And then eventually they learned how to do this with a swath. But this is a very time-consuming process, and in fact, a lot of the seafloor is not mapped by this process because the seafloor is so enormous. We've done a better job getting the whole seafloor mapped with satellites. This is one of my favorite pictures. It's a little weird, but what they've done here is they've shown you the tracks that have been mapped on the seafloor from somewhere in the Southwest Pacific. And they've superposed it onto a map of the US to show you that there are places as large as the state of Colorado that have not been mapped by this process. So I just think that's kind of cool. As I mentioned earlier, there are two kinds of continental margins. There are active margins and passive margins. And active margins are where people are running around a lot, and passive margins are where people are sleeping. Just kidding. Just seeing if you were paying attention. Okay, active margins are the edges of continents where there's some sort of plate tectonic boundary. And a plate tectonic boundary is where two plates are interacting, and in this case, they're usually coming together. A passive margin is like the one I was showing you off the east coast of North America, and there's no plate tectonic boundary involved. So when the narrator mentions plate tectonic boundaries, that's what she's talking about. Now over here, I've put arrows to show that these two plates are actually moving towards each other, and that's the South American plate, which is shown here, and then there's a plate over here called the Nazca plate, and we're going to learn about this later on in the semester, but they're moving towards each other, and so the features on this margin are different than the features on a margin where there's no interaction of two plates. This type of plate boundary where two plates are moving towards each other is called a convergent plate boundary. And the one we were just looking at is here, and it's produced something called a trench. So when two plates come together like that, one of them tends to bend down, and that low V shape right there is a trench. And so around much of the Pacific are these trenches that are produced from convergence between two plates like that. That's what's shown here, and it's also referred to sometimes as the ring of fire because, I'll go back here, you often get volcanoes forming above this region, which is called a subduction zone. So the ring of fire is this ring of active volcanoes all around most of the Pacific. Now, the San Andreas Fault is not a convergent region, so we'll talk about that also in a few weeks. You'll hear this in the video, and I just wanted you to be aware of it. Some other things you'll hear about include the abyssal plains of the seafloor. Now, this is that same area I showed you earlier. This is a little bit less vertically exaggerated, but we still have the passive margin, the continental shelf over here. Abyss means without bottom. A is without, abyss means bottom. And so the abyssal plains are these flat, very deep plains out here. And then again, we have these mid-ocean ridges, and if you looked at a profile from A to B, you would see that there's a very steep drop at the margin, and then it's fairly deep, and then these mid-ocean ridges are actually elevated compared to the seafloor on either side. And that's because even though things are being pulled apart, as these arrows are showing, okay, so things are being pulled apart, but there's magma underneath there, and so it's actually pushing it up. So even though they're moving apart like this, they're being elevated because there's magma right here creating new seafloor. So they're being pulled apart like this. And that's why this is elevated right here. And these are called divergent plate boundaries. And here's an example of where they are. This is that mid-Atlantic region that I showed you earlier, but it kind of wraps around to the Indian Ocean. It goes south of Australia, between Australia and Antarctica. It comes back here through the Pacific, and it actually goes right up into the Gulf of California and connects with the San Andreas Fault system. That is a really, really quick overview of some plate tectonic features. Again, you're not going to be quizzed on this aspect of the seafloor, but I do want you to be aware that there are ridges and trenches in the seafloor, and they're related to how plates move relative to each other. So coming up next, there are 3 videos from the City College of San Francisco. The first one is an introduction to oceanography and the water cycle, which we've talked about a little bit already when we talked about meteorology. Then you're going to get a video about seafloor features and landforms. And finally, the fascinating seafloor sediment. Always a favorite with students. Have fun.